Hi there, everyone. Good morning, afternoon, and evening. The authors and invited guests, welcome to the technical session 3A. Let me just share my screen. I hope my screen is visible. So, dear authors and invited guests, welcome to technical session 3A. I'm Sansriti Kamkar, and this session will be moderated by me. On behalf of Global Knowledge Research Foundation and GR Scholastic, it is my great pleasure to welcome you to the 11th International Congress on Information and Communication Technology, that is ICICT 2026, London, UK. The 11th edition of the conference is being organized in a hybrid mode. The physical event was held yesterday in London, UK, and the virtual event is being held through Zoom from 25th to 27th February 2026. I hope you will all enjoy the knowledgeable and interactive sessions through the day. In this session, we have 6 presentations. Each presenter will be given 12 minutes for the presentation and 3 minutes for question and answers. After 20 minutes, I will raise a gentle reminder. I request all the participants that you will stay connected with us till the closing remarks. If you have any query or update, then you can write it to me in the chat box. Now, before we start the session, I'd like to introduce you all to the chair for this session. First, we have Dr. Prince Rikrit, the Professor and Academic Director, Fin School of Business and Tourism, Bangkok, Thailand.
All right. Oh, you want me to speak? Okay. Yeah, nice to meet every one of you. So yeah, I am happy to see you all, and I plan to help you with this one as well. So if you have any questions, or I may have some questions at you, I will answer this one. Okay, thank you very much.
Thank you, Dr. Surikrit. Dr. Surikrit is presently working as a professor and academic director in Fin School of Business and Tourism in Bangkok, Thailand. With a doctorate in business and specializations in blockchain, IoT, and AI, he has more than 20 years of combined executive and academic experience. His expertise lies in cultivating strategic partnerships, driving educational excellence, and steering technological innovation. Our second session chair is Dr. Preeti Parvekar. Dr. Parvekar is a professor at GITAM University in Hyderabad, India. She is a professor in the Department of Computer Science Engineering. She has been an academician for the last 23 plus years. She's a member of IEEE, ACM, and CSI. Her research interest includes Internet of Things, cloud computing, machine learning, wireless sensor networks, software engineering, and information retrieval systems, social media, and data mining. Welcome, Dr. Parvekar.
Yeah, thank you so much. Hello, everyone. Looking forward to listen to your research papers. So I think we can start with the first one.
Yes, sure. Okay, so now let's start with the papers. First up, we have a paper on wearable sensor system for monitoring the risk of fireground injuries among firefighters by Alan Vikiru and Esther Thakata. I'd like to invite Alan Vikiru to present the paper. You may please start your presentation.
Thank you very much for the introduction, and greetings to everyone from Nairobi, Kenya. My name is Alan Vikiru. I'm here to present my research titled A Wearable Sensor System for Monitoring the Risk of Fireground Injuries Among Firefighters I'll be presenting on behalf of my co-author and my colleague, Dr. Esther Kakata, and I hope we can, it will be a very interactive session. So allow me to share my screen. I believe we can see the presentation. If not, feel free to let me know if anything's amiss. So again, thank you so much. So yes, this is my research titled A Wearable Sensor System for Monitoring the Risk of Fireground Injuries Among Firefighters, presented to the ICICT 2026 conference. My name is Alan Vikiru, member of faculty from Strathmore University here in Nairobi, Kenya, together with my co-author and supervisor for this study, Dr. Esther Kata, who is also a member of faculty here at the school. And first off, we're very grateful to the organizers for this conference and the reviewers for this paper who shaped, whose feedback shaped well into this research. Just to give an idea of what we'll be discussing today, just to discuss the background of the study, what's motivated for us to explore this topic, and some related works that guided the development of the work, together with the methodology or the steps taken in developing the study itself and the results that I've received at the end of the research. We'll finally conclude with some remarks and future plans and open up the session for question and answer. So as a background to this study, we're looking at workplace injuries within the context of Kenya in itself. So Kenyan workers experience quite a lot of injuries that affect their productivity and health. And much as there has been limited work done on how this has affected Kenyan firefighters, it has been shown that workers in other service industries or other similar industries like construction, motor vehicle repair in Kenya, and firefighters worldwide also have a high chance of experiencing such injuries that may lead to affect their health negatively. And particularly in Kenya, we look at the fire services themselves, which are offered in either the private sector or the public sector. So with this, we're focusing on the public services offered by the national, county, and local governments. Unfortunately, they're quite not well equipped to handle such events as they occur, which really or dramatically increases the chance of these firefighters sustaining these injuries. So you find that from them getting to interact with the fire environment, they may experience issues such as smoke inhalation, burns, thermal stress, which really increases or reduces the chances of their productivity as workers. With this, we're coming into the technology aspect where we are looking into wearable technology, which is developed by Internet of Things technologies. This has been rapidly taken up to enhance physiological monitoring the status of these firefighters, where you look at parameters such as the heart rate, the body temperature, as well as those of the environment, to find out or to track how they are performing as they carry out their duties, while also looking at these wearable technologies facilitating communication among fire personnel within the field. So with this, we now come into this study where we're looking at a data-driven technique or data-driven approach through a wearable device prototype and a monitoring platform that allows for real-time monitoring and analysis of the health of firefighters, because as a chance or as a measure to reduce the chances of these injuries or fireground injuries, particularly affecting these firefighters while they're in the field. To guide how this study was done, we looked at 4 particular papers that were similar to what we have developed. One is by Garrity and Yusuf, which looked at a device that records environmental temperature and generates alerts based on the rate or the high or low temperatures that they may experience. And communication was done over radio frequency bands. And the device used an SD card to store all these parameters that are being generated and the alerts that are coming off. So with this, we found that there's a potential to introduce or have more parameters being monitored, while also taking advantage of remote storage, particularly cloud storage, to allow for much more scalability for this device. In Choi et al., we're looking at a smart helmet as a wearable device, which had a heart rate sensor, an infrared temperature sensor, and accelerometer. that was able to communicate with an application that was set off-site using LoRa technologies and Bluetooth Low Energy. So with this, the authors themselves recommended to introduce GPS tracking for these firefighters and also replace the Polar OH1 sensor with the MAX 3100 to support much more high-scale capabilities for heart rate monitoring. In Chai et al., we looked at, Chai et al. Focused on fall detection among firefighters using motion sensors. So with this, it used two communication technologies, Wi-Fi and LoRaWAN. So Wi-Fi was from the suit itself to the helmet, where the sensors have been stored, and to the helmet, which would communicate with the gateway on the fire truck. Then from the helmet itself to the fire truck, it used LoRaWAN. And with this, it had an algorithm for fall classification based on decision trees. And with this, we saw a potential of it getting or having a lot more sensors that can be put together or can be accumulated to see the dynamic nature or to capture the dynamic nature of these injuries as they occur. Then lastly, with Hija, we developed a smartwatch to measure the firefighters' heart rate, their step count, as well as their GPS monitoring. So with this, it communicated with a waste relay device, which pushed data to a backend for storage and for further analysis. And with this, it used LoRa and 4G or GSM, which was very close to with what we have developed with this study. And with this, we saw potential of adding a lot more environmental parameters, particularly because they also have an effect on these firefighters sustaining particular injuries. So with this, we come to the developed architecture that guided this study. We have two particular components, which I'll point out with my laser here. So we have the wearable device that is worn by a particular firefighter, which has three particular sensors, one to measure the external temperature and relative humidity, the GPS or location of this firefighter, and their heart rate values as they wear the device. This data was being communicated or transmitted over GSM or 4G networks to a cloud platform where it would be stored and analyzed to present much more varied charts with the monitoring dashboard that other fire service personnel within the ground can be able to track and monitor these firefighters in real time. So to give an idea of the tools and techniques used with this project, in terms of the hardware, we worked with an Arduino MKR GSM 1400. It was good because it is compact and it has an embedded GSM module attached to it as a mic controller, and the three sensors to measure temperature and relative humidity, DHT11, to measure the location or to read the location Neo6M GPS, and MAX 3102 as the heart rate and pulse oximeter sensor to read heart rate values. In terms of the software, we used Arduino IDE to develop the wearable device prototype, Fritzing for the designing of this particular prototype, and ThinkSpeak as the platform as a service or the cloud platform that would be able to transmit or send data or receive data rather from the wearable device for further analysis and visualization for fire service personnel, and some techniques that were applied on reducing the number of blank items or blank data items was by nearest non-zero and linear interpolation, which I'll discuss shortly, as well as a linear regression score to look at the relationship between particular variables. The choice of communication technology was GSM or LTE 4G, particularly over MQTT or over HTTP. Why did we choose this? Because of the inbuilt security it allows for or covers within the GSM architecture, as well as the coverage countrywide. Actually, Kenya is well covered in terms of 4G or GSM technology. So it would allow for fire services across the entire country to get access to this technology. So onto the results of the actual system. So this is the developed prototype. So far, this is the PCB model that was created. So we have the mic controller at the center here being powered by a 3.7 volt battery. To this mic controller, we have the DHT11 temperature and relative humidity, where my pointer is. We have the MAX 3102 for measuring the heart rate. We have this as the GPS. So this would get transmitted or rather managed by the mic controller, and the data would be transmitted via the antenna here through the GSM or the 4G network. Just an idea of how it performed, we first established 3 key tests to see or to test its functionality. First was to see whether it's connected to the 4G network over HTTP, which was quite successful. We received a pass at that. And the next bit was to look at MQTT. So we were focusing on working with MQTT because of the additional security features it captures, considering we're working with very sensitive health data. So over an unsecure MQTT network, it worked perfectly, where we were able to visualize the ThingSpeak data on ThingSpeak as it was. But over secure MQTT network, it was impossible. It failed at that because there was a slight conflict between the security certificate that was presented, or the security library, code library, and the heart rate library. So that one was unsuccessful, and we resorted to working with 4G over a secure HTTP network. Results of the monitoring dashboard. So this is what the other fire service personnel would get to see. If I may zoom in. So this is focusing on a particular firefighter, can get to see different parameters that are being measured by this device, the heart rate as it was, the location by which they're going to be traversing across a particular region, and the current air temperature and air humidity, all in widgets and dashboards and bulbs that are easy for this personnel to get to interact and understand more about how this firefighter is faring on, and to focus on two particular visualizations within this dashboard. Sorry. Okay, good. So to focus on two particular visualizations, we're looking at the heart rate against temperature. This one was selected because we see that high temperatures affect or drastically affect firefighters because it increases the chances of getting exhausted and experiencing heat stroke. So we can see it was quite a varied relationship between the two. And here imputation, or getting rid of the null items, was done by selecting the nearest non-zero item. So every time there was a zero within the data stream, it picked on the last item that was not a zero and worked with that in terms of the visualization. Then next is a plot between the temperature and relative humidity. So here the plot, as you can see, is a linear relationship between the two, where an increase in temperature has a corresponding decrease in relative humidity. With this, the imputation, or getting rid of the null items, was done by linear interpolation. So there was a model that was fit to on this relationship, and any null values was fitted against that particular model. The relationship that we were able to identify based on the collected data was as presented in this equation here, with an R-square score of the model generated to be 0.44. Not as perfect, but we attributed it to the noisiness of the data that was generated or collected while testing. So with this, with what we've discussed so far, it's looking at... Yes,
I'm
please.
sorry to interrupt you, but your 12 minutes are, but please wrap it up, because we
Yeah.
will be needing a few minutes for question answers as well.
No problem. We'll do so. So just to quickly wrap up, we looked at a low-cost architecture that can be used by resource-constrained contexts or resource-constrained regions like Kenya that cannot support very heavy equipment. So this can be adopted towards that. Those are the next steps. We're looking at enhancing the functionality of this device, particularly by these two particular items, deep learning or edge processing for advanced real-time analytics, or much more powerful sensors and microcontrollers that can support higher functioning of this device, as well as low-cost communication technologies such as low-range and NB-IoT to reduce the capacity that will be taken by the transmission of this device, as well as looking at the acceptance testing to ensure that fire services are able to use it and will be willing to work with this particular system. Thank you for your time. We've come to the end. These were the references used in this study. And we will welcome you for any questions that you may have. Thank you so much for your attention and your time.
Yeah, hello, Ellen.
Hello.
Yeah, this is very nice work you have done. I have some couple of questions for you. It's like, would you tell me what type of sensors have you used in your research?
Yes, so we used the DHT11, temperature and relative humidity, to measure temperature and relative humidity. We used the Neo6M for measuring the location. That's based on the GPS system. And we use the Max 3102, which is to measure the heart rate values of the wearers of this device.
All right. Since it is a firefighting, so along with the temperature and humidity, it would be nice in your future work if you can consider the wind speed also, the direction of the wind and the speed, because that would be another important parameter which can be added. And as I understand it, the study has not been done on the real time, am I right? The real firefighting system. So when it's really happening, then the wind matters a lot because in which direction the fire is going, that prediction has to be done. So have you done the classification? You have mentioned somewhere. Have you used a classification using the machine learning algorithms?
The algorithm that we worked with was a regression just to
Okay.
do a prediction between temperature and relative humidity.
All right. And have you used cloud for the storage?
Yes, we have through the ThinkSpeak platform. Yes.
All right. So maybe that would be the suggestion that you can include the another parameter as well, and you can carry out your research. Nice work. All the best. And before
Thank you
I
so much.
ask the another session chair, hello, Dr. Prin. This is Preeti from India.
Hi,
Yeah.
nice to meet you.
I'm
Yeah.
sorry, I forget to say hi to you.
Hi, sir. Yeah,
Nice.
I will comment a bit on the business side. So yeah, thank you very much
Yeah,
for
I
commenting
know.
on.
I could see your profile because you're at business end and I'm a technical, so we have a balance now.
Okay.
All
So
right.
Alan, yeah, okay, everybody, thank you very much for this. Yeah. And Alan, I think the thing is your is nice, except I want to I suggest to add more on the warning system. Like this like when it this when the heart is quite high, then you should alarm to go back like that. Or someone have to help him like that. You don't mention in that one. And that's a key of the system in the business like that. Because the key of this is we want to save life. So how can you alarm for tell the firefighter to go back or someone to save him? Yeah, that's it for me.
All right. Thank you so much. Thank you for that comment.
Next up, we have Ilan Belby and a paper on application of artificial intelligence in digital marketing communication and its development plans.
Hello, everyone. I hope you can see and hear sharing. Sorry. Stop share. Sorry. Dash share screen. So yeah, can you see the presentation in full screen?
Yes, we can.
Yeah. So hello, my name is Liana Kaibe, and I'm from University of Latvia. And together with my colleagues, professors Jelena Shalkovska and Anna Batraga, we conducted the research and wrote a paper titled "Applications of Artificial Intelligence in Digital Marketing Communication and its Development Trends." Aim of this research is to evaluate and the possibilities of using AI and analyze development trends in the digital marketing communication of Latvian companies, and of course develop proposals for improving the digital marketing communication of Latvian companies. To reach the aim, we conducted semi-structured expert interviews with 6 experts. Experts were selected by experience in digital marketing or artificial intelligence. And also, we conducted online survey of company representatives, together 238 participants. Screening questions ensured respondents use digital marketing. So, opportunities enabled by AI. AI enables that data-driven decision-making process optimization and innovation. It enhances efficiency of resource allocation, lower operational expenditures, and supports managerial conditions for more informed decision-making. Also, predictive analytics and machine learning helps identify weaknesses, enable proactive corrections. For example, Rolls-Royce and Siemens in predictive maintenance. And AI use historical data to anticipate consumer needs, enabling personalized offerings and proactive communication strategies. Challenges when companies use AI in digital marketing communication. It are ethical and practical challenges that includes algorithmic bias and the risk of losing trust and authenticity through excessive reliance on AI-generated content. Barriers include the need of technological infrastructure and skilled personnel, contributing to an unequal competitive environment for small and medium-sized enterprises. And also, data quality and availability are critical. Incomplete data can lead to inaccurate predictions from AI. AI systems often collect and analyze large volumes of personal data, and that increasing risk of cyber threats and legal risks for companies. And also, there's privacy paradox that consumers want personalization while they maintaining high data protection. And in Latvia, consumer-facing AI and marketing should reflect fairness, transparency, and shared responsibility to maintain trust. It's very important to our consumers. And some results from our paper. AI extends automation of digital advertising, target audiences selection and performance optimization. Generative tools can create multiple ad versions, enable dynamic personalization, which is really important for consumers. Consumer response vary by messaging type. AI is described as more effective for factual competence achievement-oriented messages. Authenticity might decline for emotional messages if AI authorship is not disclosed. And we had a Latvian example, a case study from Riga International Airport highlights sustainability governments and stakeholders' engagement to inform responsible introduction of AI-enabled data-driven marketing communication in transport services. And transparent data processing and privacy compliance are described as essential to maintain trust. AI use in Latvian companies' digital marketing is described as fragmented and uneven. Larger companies, for example, banks, telecommunications, and the airport, mainly implement AI in CRM systems and personalization process. But small and medium-sized companies more often try individual tools without strategic integration. Many companies are not aware of the extent AI is already used via Google or Meta algorithms for personalization, optimization, and retargeting when they are using ads in these build platforms. Common tools mentioned by experts and companies are ChatGPT and similar text generation tools, Midjourney and Canva, algorithms built into Google and Meta platforms. And some of respondents also use chatbots, personalization, recommendation systems, and email automation in e-commerce. Universal, accessible tools dominate. Personalized, in-depth solutions are described as rarely used. And some key findings from our research are that AI use in Latvian companies' digital marketing is at an early and fragmented stage. Larger companies integrate AI, but SME mainly experiment with individual tools. Digital marketing channels use is widespread, but more complex AI solutions are used less frequently. Among AI users, text generation and performance analysis, insights, and content reuse are most common. Main barriers include difficult selecting tools, legal regulation risks, data confidentiality and security concerns, lack of time and skills. Expert interviews highlight perception and quality risks. along data security, authorship, manipulation risks, requiring human oversight and responsible management. Planned expansions emphasize data-intensive use case, customer behavior analysis, personalized communication, and customer feedback analysis. Overall, the direction points to normalization of AI in digital marketing with strategic integration and skill development as critical. And some proposals from our research: develop a company-level AI strategy linked to marketing goals and KPIs. Develop a structured tool selection and evaluation framework to address difficulties, select appropriate tools. Adopt hybrid AI plus human content creation model. AI for scale version generation, humans for creativity, fact-checking, brand tone, and ethical filtering. Invest in data quality and governance process to support accurate forecasting and personalization. Develop ethics, privacy, and compliance protocols consistent with EU regulations. Prioritize employee skill development. Create a culture of experimentation via controlled pilot projects and measure impact on productivity and accessibility. For example, A/B testing. Create a measurement system for AI investments to provide evidence of a return on investment. Thank you for your attention.
Yeah. Hey, Eleni. Hi.
Hi.
I guess this is a study paper, am I right? In artificial intelligence.
Yeah.
Yeah. So, what's your plan? I mean, what's your future plan? Study is okay. You have done the studies, you have identified the challenges and the problems. So, the other side of the AI, what could be the challenges and the problems? So, what is your next plan? Are you planning to implement something?
No, right now we are not trying to conduct further researches. We have like these challenges. We collected them, and then we are open to discuss this with another researchers, or like for those who are ready to deep dive in these topics, or to implement something to develop and overcome these challenges.
All right. So you can pick up any of the challenges, and yeah, good luck for your research. The study is good.
Yeah.
Yeah.
Yeah. Thank you.
That's all from my side.
Okay, from my side a bit, as I am the ISO 42001 lead implementer as well, so please beware on the how to use data, because if you use on this one, you may get problem with the law in the future. So when you get the data from, and I'm not sure you did it or not, but it should be do like when you get the data, you should get it. You cannot track back to know who is it. Okay. Now, if you, or even if you use the camera or anything that you can track, you just want to check that is it go back, is it can go back to the one to do it or not. If it can go back, then you may have to pay a lot in the future. So beware for this one as well, especially in the marketing side. Yeah. Okay, that's it.
Yeah. Okay. Yeah. Thank you.
Thank you, Amy, for your presentation, and our session shares the valuable feedback. Next up, we have Rotimi Williams-Bello with his paper on artificial intelligence and sustainable development in South Africa, innovation and infrastructure for Sustainable Development Goal 9.
Good morning, everyone. Let me share my paper. Can you see my screen?
Yes, your screen is visible.
Can you see my screen?
Yes, we can.
Okay, thank you. I welcome all of you to ICICT 2026. My name is Dr. Ruth Bello. I am from Swan University of Technology, South Africa, where we empower people. I will be talking on artificial intelligence and sustainable development in South Africa, the innovation and infrastructure for SDG 9, Sustainability Development Goals. I'm coming. Let me make a full screen.
Yeah, Dr. Rotmi, can you put it on full screen presentation, please?
Yeah, that's what I'm trying to do. I've done that now. Can you see that?
Yeah, it's visible. Much better. Yeah.
Yeah. So, this paper explores how SDG 9 is supported or impeded by AI ecosystem of South Africa, including adoption levels, infrastructure readiness, and policy framework. To evaluate the contributions and challenges of AI for sustainable industry and infrastructure, we drew on recent government reports, international assessments, and academic analysis. Specific case studies such as urban planning initiative illustrate on the ground impact of AI. Since the influence of AI spans multiple sectors, we also examine cross-cutting intersections with other SDGs, such as SDG 4, which is for education, SDG 7, which is for energy, SDG 8, which is for economic growth. Finally, systemic barriers were identified, notably the digital divide, digital skills gap, and regulatory lag. Moreover, policy and investment recommendations were proposed to ensure an innovative, inclusive, and sustainable future are supported by AI in South Africa. Problem statements. Key barriers such as the digital divide, skill shortages, and regulatory gaps to attainment of United Nations Sustainable Development Goals are yet to be addressed, especially in South Africa. The aim of the research is to examine the impact of AI on SDG 9 for industry, innovation, and infrastructure. Our principal objectives are to review the adoption of AI and policy landscape in South Africa, to analyze the key barriers, such as the digital divide, skill shortages, and regulatory gap, to offer evidence-based policy and investment recommendations to harness AI for innovation, infrastructure, and sustainable industry in South Africa. As we can see from this figure, artificial intelligence and sustainable development in South Africa comprise the innovation and infrastructure for SDG 9. From the AI to the human brain behind AI evolution for SDG application, we can see that the AI has innovation to give, infrastructure to give, while the man behind the AI application conduct research, and the research also applies to smart cities. As the AI is being conceptualized by the human, you can see how it's being translated to SDG 9, which is the industry, the innovation, and infrastructure, down also to the smart city, making infrastructure, smart cities, what we can derive from AI evolution and how we are to be able to help SDG 9. The AI landscape of South Africa comprised majorly of the adoption of it, the infrastructure of it, and the policy behind making it accessible to the citizen. The essence of this figure 2 is to make the awareness of what impact the AI has done concerning boosting the SDG9 by adoption, by the infrastructure, and by the policy made by the authorities of South Africa. The notable barrier to practicing it or to adopting it or to making it go round all the citizens of that country is the skills gap. There are so much gaps in the skills of people that are expected to adopt the services rendered and the benefits rendered by AI. The regulatory and the ethical issues surrounding it also is another barrier. You know, different countries with their ethics usage of AI, the regulatory surrounding it. Some make it easy accessible to the male, while the females are debarred from it. Some debar from the children, while some let it be open to adults. And in this generation that we are, we all know that even the children, I mean the adolescents, they have the capability to lay their hand on AI devices and exploit a lot of things. But due to some regulatory and the ethical issues surrounding allowing such underage to make their hands lay on the AI tools, you know, we might not be able to get a lot of contributions from all those youths. If the regulatory can make it enough, if the policies can allow the youths to exploit what talent they have, in addition to the AI explosion, that will be able to contribute to economic of any nation. But due to the regulatory that debar them from such, it's a lot of barrier to developmental achievements of so many countries, especially the South Africa that I'm looking at. And the frustration on accessibility is another thing. You know, I've just talked about the accessibility now. It is not easy for some countries, especially this country, to lay their hand or to have access to the AI devices that could boost SDG 9. They are looking for how to boost innovation, infrastructure, and all the rest. But the AI that is supposed to help in this manner, they are not easily accessible by the citizen, by the workers that are supposed to be the one to make it AI leverage for SDG 9. That's why I said this figure 3 is a notable barrier to the South Africa leveraging AI for SDG 9. Here I look at the policies and investment recommendation. I look at the strengthening digital infrastructure. I talk about the development human capital. I talk about the regulating proactively for ethical AI. I talk about supporting innovation and entrepreneurship. I talk about promoting inclusive AI deployment. And also I talk about fostering collaboration and governance in strategy. If I say I should be explaining them one by one, that might take my time, but by the bullet, you can see with the caption that I put into it, I have already explained it. For the policy and investment recommendation, we have to strengthen digital infrastructure, we have to develop human capital, we have to make a regulatory proactive for ethical AI, we have to support innovation and entrepreneurship, we have to promote inclusive AI, etc., etc. The conclusion here is that South Africa is moving towards utilizing AI for significant progress acceleration of its development goals. But this can be facilitated only if careful policy and investment decisions are made. A relatively advanced ICT-based and a burgeoning AI research community are possessed by the country, giving it an advantage over other countries in the region. However, entrenched challenges such as the skill shortages, digital divide, and regulatory gap threaten to thwart this potential. South Africa must ensure inclusive innovation to harness AI for SDG 9 and related goals. Workforce upskilling and digital divide bridging are essential as building data center and fiber networks. Equally, building trust in AI applications will be by establishing clear ethical regulations. Sovereignty infrastructure challenges should be reason for investing in AI and not only for novelty. You see, in that country, some policies is always after novelty of, people want to see the novelty in the research that all the institutions are conducting. Nobody is even talking about how to even invest in the AI in order to fulfill all the recommendations that are given in the prior slides. They are just after the novelty of a research without having the positive implication or benefit on the citizen. It's not really, it's not worth it. So as you are looking for novelty in the research, it should also translate to world impact. It should be able to be felt. You should be able to deploy it. People should be able to feel the novelty of the research. It should not be only in paper. It should not be only in publication. People should see it working in their life, especially on this SDG 9 that cut across innovation infrastructure. Finally, that is all I have to give this morning. Question time, if there's any question. Thank you.
Yes, thank you, Dr. Rotmi. And what is your plan to have the ethical regulations? What is your next step? What are you planning to do?
I have said it. Artificial intelligence is a new dimension that every nation is working towards. So we want to publish this paper to give the awareness to the country as a whole, for them to know that more are still expected from the country, from the government concerning SDG, particularly SDG 9. We want to let them know that artificial intelligence should not just be what we should be researching into, but we should also put in mind area of its application in the country. We have so many things that need attention in the country, but particularly the SDG 9. We want to see all the triumph, all the progress, all the achievement that we are having from the AI. We want to see how they can be applied in SDG 9. That is the essence of this paper. We believe that by its publication, when it gets to individual offices, they will be able to call their attention to what it's in the paper, because a lot are in the paper itself that we are expecting them to come across, read it, and invite us for what we think that they can do concerning the paper. Because our expectation is to make sure that the agenda of SDG 9 is achieved by the AI, but government is not putting their interest into that area, and that is why this paper is trying to address the benefits that they are going to derive if they can channel the good things offered by AI into SDG 9.
All right. Wish you all the best for the implementation, and
Thank
hopefully
you so
you
much.
can put the AI for the innovations of SDG 9. Good luck.
Thank you so much.
Okay, for me, just on the because SDG 9 is about industry, innovation, and infrastructure. So
Yes.
That's only two short questions. Do you think how can African practically address the skill shortage needs to support AI-driven in the future?
What do you say, sir? I can't hear you.
Sorry, how can South African practically address the skill shortage need to support AI-driven in the future?
Yeah. I particularly I said this thing is for South Africa, and government need to release more money. I think the research institutes in South Africa need more money to conduct research. The result from that research will be applied into SDG 9, which is the industry, the innovation, and infrastructure. There can never be any innovation if there is no research, and there can never be research if money is not released into the research institute. So when they release money to the research institute, the research should be conducted towards actualizing the SDG. And what are those things that we are trying to target is the three things there: the innovation, the industry, and the infrastructure. If these three things are put into place, life will be improved, living standard will be improved. There will be less criminal, or the crimes will be reduced. Life will improve, everything will be fine, because we believe that society is surrounded by, for any nation to develop, the infrastructure, the innovation, and the industry of that country need to be put in place. That is why we are targeting. We have SDG 1 to 17. There are a lot of SDGs, but we really have interest in the one that we call the SDG 9. So many SDG from 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 to 17. But we target this particular 9, believing that if innovations are put in place, when people are encouraged to go for innovation, the innovation are applying to industry, there will be infrastructure development. That is the essence of all this thing. So we advise every nation to please channel their AI talent into SDG 9 for the development of the 3 things that comprise in the SDG 9.
Okay, thank you very much. Understand.
Thank you so much.
Thank you, Rati and session chairs, for this
Thank you.
engaging discussion.
Yeah.
Up
Thank
next
you.
is Funmi Adebasan with a paper on digital phenotyping in healthcare, opportunities and challenges. Funmi, may you please share your presentation?
Okay, thank you very much. Can you hear me?
Yes, you're audible.
Okay, I'm just going to share my screen. Are you able to see my screen?
Yes, we are.
Okay, thank you very much for the opportunity to do this presentation. This is a study conducted by one of my students, Chloe Brandt, but unfortunately she can't be at the conference, so I am presenting on behalf of the students. So this was a systematic literature review on digital phenotyping and the use of digital phenotyping in healthcare and the kind of opportunities and challenges that could ensue from them. Okay, so this is the outline. I'll look at the introduction, the methodology that was used, the results, key findings, and concluding or closing remarks. So as we are all aware, there is a lot of advancement in technology. There is growth in mobile phone ownership. There is growth in smartphone ownership. And what we see that what this creates for us is an opportunity, especially in the healthcare space, for us to personalize healthcare. So currently, the statistics on the global ownership of smartphones is that we're at about 70% of ownership of smartphone worldwide. So with increasing ownership of global mobile, especially smartphone, there is opportunity for us to be able to use smartphones and new technologies to personalize our healthcare. And what is personalized healthcare or personalized medicine? It involves the integration of personal data to provide tailor-made medical interventions as opposed to a one-size-fits-all medical care. And one of these areas of opportunity is what we refer to as digital phenotyping, which involves continuous and passive collection of physical, biological, and behavioral data. So this is done obtrusively without the individual that is wearing the device, in the case of wearable device or mobile device, being aware or not necessarily knowing that this is being done continuously. So if we take, for example, someone that is at risk of depression. So if we, based on the data that we collect from their movement, if they are moving less, if they are sending messages to their relatives, if those messages, if the exchanges are less, then we can see that, okay, perhaps this person is relapsing, perhaps they are going to a depressive state. Or if you consider someone that has a bipolar disorder. So if they're starting to sleep less, which is data that you can get from their mobile device on their wearable, or they are becoming more active or extremely active on social media platforms, then you can show that perhaps there is a signal for a mood, some form of mood shift. So the methodology, as I've mentioned, this was a systematic literature review using the PRISMA guideline. The main research question that was addressed is what are the opportunities and challenges of digital phenotyping in the healthcare sector? So 4 databases were used: IEEE, SAGE Publications, Science Direct, and Scopus. So a combination of search phrases from the keywords that are relevant to the questions were used. Those search words are shown on the screen. I'm not going to read them. So, but the only peer-reviewed studies were considered. We did not include review studies. So SLR studies, scoping reviews, and so on were excluded, and the data were extracted. Only studies that were published from 2019 up until April 2024, when the studies were retrieved, or the papers were retrieved. So this is how the selection process looked like during the identification phase. So we identified a total of 141 studies. IEEE, there were 14 studies. SAGE, there were 47. Science Direct, 319, and 61 from Scopus. So a total of 28 duplicate studies were retrieved, and that's left 413 studies. So thereafter, another 17 were excluded, with 6 being non-English. Abstracts where abstracts are not available, we excluded 2 of those studies. Then further screening was done to assess the eligibility of the remaining studies, and out of the 405, a total of 369 studies were excluded because they did not relate to the use of digital phenotyping in healthcare. And in total, 36 studies were included in the systematic literature review. So the data were analyzed using both descriptive statistics and qualitative content analysis. So just a highlight of the quantitative results. So we see that from Scopus, a total of 15 studies were included in the analysis. IEEE, there were 4, SAGE 7, and Science Direct 10. So in terms of the document type, most of the papers included or analyzed were journal papers, 34 of them, and the remaining 2 were conference papers. In terms of the year of publication, we see that in 2019 and 2020, there were 4 studies published, that is, the ones that were analyzed. In 2021, we see a spike at 15, and then it starts to taper down. 6 respectively in 2022 and 2023, whereas in 2024, there was only 1. And the 1, we can account for it based on the month of the year that the studies were retrieved. They were retrieved in April 2024. Okay, so in terms of the qualitative results, so the qualitative content analysis yielded 5 main areas of opportunities for digital phenotyping in healthcare. So the first one, we see that digital phenotyping could support objective and accurate data collection. This were retrieved, or they were extracted from 9 of the studies that were included. So by retrieving or by collecting personal health and behavioral data passively from your smartphones, from your wearable devices, you are able to track both social and physical data from individuals. And this is more effective compared to the traditional method of having to ask a participant to complete surveys, for example. So you are able to track in real time what people are doing or what their physiological data is all about. Secondly, the second area of opportunity is that we can integrate, digital phenotyping can support integration with precision medicine. So this theme was identified from nine studies. And we see that digital phenotyping, it can also enable us to, because of the physical and biological data that you are collecting, you are able to tailor the care to the need of individuals instead of the traditional one-size-fits-all care that is used in medicine. So it can also help us to improve the scalability of data collection in remote, especially in remote areas. This theme were derived from 7 studies. And because of, we see that there is increasing connectivity, computers are connected, mobile devices are connected to the internet. So this can assist us to be able to reach, hard to reach communities in terms of collecting data, especially when you need to involve them in research. Also, we see that digital phenotyping can support mental health research. In fact, this is one of the main areas or the main field where digital phenotyping is being used. So if you combine behavioral data collection with other data collection from perhaps from social media, from sensors and so on, we're able to detect where there is, changes in mood, people with bipolar, you are able to determine whether they are going to relapse, and you are able to target the kind of care that they need. And finally, we see that digital phenotyping can also support equity and inclusion in healthcare. So by collecting behavioral data from diverse population, because now you have the opportunity to include several people, even those that are in hard to reach location in your research. So the study also analyzes papers that were included in the SLR to determine some of the challenges that could ensue or that faces the use of digital phenotyping in healthcare.
Sorry to interrupt.
And
just
pardon?
a gentle reminder that 2 minutes are left in your presentation.
Okay, I'm going to wrap up quickly. So the number of challenges, one of the greatest one is ethical concern. So people are concerned about privacy, they are concerned about the security of their data. Okay, another area of concern is the technical challenges. For you to be able to continuously collect data, you need long battery life from the devices. You need compatibility between the devices. So these are some of the issues that could derail the use of physical phenotyping. So in addition to the content analysis, so a SWOT analysis was also done to determine what are some of the strengths, the weaknesses, the opportunities, and threats to the use of digital phenotyping. Perhaps one of the greatest strength is the accuracy in terms of the data collection, because now you don't require the end user to input data by themselves. This is being collected passively and continuously. One of the greatest weaknesses is in terms of the technical limitations. So you need long battery life, you need compatibility between devices. In terms of opportunity, so digital phenotyping can actually expand healthcare to people that are in hard to reach location, and perhaps one of the main threats to the use of this digital phenotyping is ethical concerns, privacy, security of data that is being collected, and not knowing where this data is going and who has access to such data. Okay, thank you very much. I think that brings me to the end of my presentation. I will wait for their questions.
Yeah, yes. Hello, ma'am.
Yes.
Yeah, this is a good study. What you have done is a phenotyping. Now, just to check the behavior and the psychology, mental health based on the data. Now, the data, when you predict, there are two categories, passive data and active data. So, have you
Yes.
included both the passive and active?
So these are passive data.
This is a passive
So
data.
what
All
we're
right.
looking, yes, passive data, yes.
Okay, so do you have any data set or you have collected the real data?
No, this was a systematic literature review to see what is out there. And
Okay.
what we are looking at in future is that, because based on this SLR, what we found is that digital phenotyping is predominantly used in mental health research. And perhaps now there is an opportunity to extend the use of this to chronic diseases. So your lifestyle disease like diabetes. In South Africa, one of the burden of disease that we are confounding us is diabetes. So perhaps this is an opportunity for the use, or there is an opportunity for using digital phenotyping for lifestyle disease like diabetes.
All right. So after doing the analysis of the data, have you observed that this phenotyping is typically found in a particular age group?
No, the data that will remember, this is a systematic literature review, and the results will be guided by what is found in the data in the papers that were analyzed.
All right. So a small suggestion that in future you may also include the combination of passive and active data for
Okay.
the predictions. All right.
Okay. Thank you
Good
very
luck.
much for that
Yeah, good luck
suggestion.
for your research. Thank you.
Thank
Okay.
you.
And for me, should be on the ethical stuff like that. Yeah, prepare for that one in the future, because they may sound about privacy concern, and you need to have an informed consent in continuous data collection as well. Yeah, because I
Yes.
think this one is nice, and I think you can make it in a business as well, and it will help people that have a problem in meeting a doctor, or someone that cannot far away and cannot see a doctor. This one can help.
Yes. Thank you very much for that. Colleagues, I have to unfortunately leave the conference because I do have another engagement, and thank you for the opportunity.
Thank you for this presentation and to the chairs for your discussion. Now we'll move on to our next presentation, which is by, I'm sorry if I'm mispronouncing this, but Ainhoa Osa Sanchez. Her paper is on explainable AI for mammographic image analysis, a radiomic approach using CBIS DDSM. Could you please share your screen? Thank you.
Do you see the screen?
Yes, it's visible.
Good morning. Today I will present our research paper, Explainable AI for Mammographic Image Analysis, a radiomic approach using CBIS DDCM dataset. This research is from the University of Deusto, EVIDA Research Group. Our presentation today is structured to take you through the entire life cycle of our study. We will begin by contextualizing the clinical challenges of breast cancer screening. Then we will explore the CBIS DDCM dataset and our comprehensive 5-step methodology, which spans from the radiomic feature extraction to Bayesian hyperparameter optimization. Finally, we will benchmark for distinct model architectures and perform a deep dive into LIM, local interpretable model agnostic explanation. Breast cancer remain a global health priority as leading cause of cancer-related mortality. While mammography is our most effective tool for early intervention, it is not without its flaws. Radiologists must navigate high image variability and the subtle, often imperceptible sign of early malignancy, such as architectural distortion or microcalcification. This leads to a degree of suggestivity that can result in missed diagnosis. To standardize this process, we leverage radiomics. Radiomics allow us to transfer standard medical image into high-throughput quantitative data, extracting hundreds of features that provide an objective, mineable database of makers. The core objective of our study is twofold. First, we aim to engineer a suite of high-performance machine learning classifiers, specifically random forest, XGBoost, LightGBM, and multilayer perception. However, in a clinical setting, accuracy alone is insufficient, so therefore our second and equally vital objective is to prioritize explainability. Using LIME, so we aim to validate that our models are making decisions based on medically relevant features. The dataset we use is curated breast imaging, a subset of DDCN. This is not just a collection of images, it's a globally recognized gold standard backed by the US Department of Defense. It includes cases from institutions like Washington University School of Medicine. And this dataset provides a high-quality DICOM images accompanied by doctor-verified regions of interest, PROIS, viral characteristics, and pathology-confined levels for both masses and calcification. Our methodology is follow as a structure. A 5-step workflow designed to move from raw pixels to an interpretable diagnosis. I will direct your attention to this figure, which serves as our visual guide for this framework. It begins with the extraction of high-dimensional radiomic data, followed by a multi-stage pre-processing pipeline to ensure data quality. The six stages involve a consensus-based focus feature selection to distill the data into a most predictable components. Fourth, we move into the development and optimization of our classifiers. These frameworks include with architecture, explainability, and interpretability. And the closed-loop approach ensures that every diagnostic output is accompanied by a transparent justification. For the data preprocessing, the first step is to convert the image into radiomics. We use the Python library Pyridynamics. With that, we extracted a comprehensive suite of descriptors, including shape-based features like volume and surface area, first order statistics, and also look into the spatial distribution of gray levels by calculating texture matrices, especially the gray level dependence matrix, also the gray level random length matrix, and gray level size zone matrix. In step 2 and 3, we integrated the separate data source for calcification and masses into a unified database, and then we initiated null value detections across all variables. In the fourth step of data preprocessing, we addressed data incompetences. For categorical variables, we assigned an unknown label, and then from continuous numerical variables, we use a Canning imputer with a K of 5. Finally, in step 5, we address the coding of categorical variables using label coding to convert non-numeric and categoricals to a numerical format. To prevent the common pitfall of overfitting in radiomics, we implement a dual AI-driven feature selection strategy. We employed both random forest and XGBoost to run feature importance. In the random forest model, importance is derived from the reduction of prediction error, and XGBoost is based on gain each feature provides to the gradient boosted objective. We did not simply choose one method, instead we select the 20 top features that represent a consensus between both algorithms. Through this process, we use cross-validation to ensure that our features set was robust across different data folds. And here you have the 20 top feature selection. In clinicals features, it was selected breast density, mass shape, margins, and sublegy. In the radiomics, it was for safe maximum diameters, mesh volumes, and surf area. Also textures and statistics. Of our results, the random forest assignment emerged as the clear leader, achieving an accuracy of 86% and a near perfect OC of 96%. To put this in perspective, our multi-layer precision reached 78 accuracy, while late GBN and XGBoost trailed slightly behind. The random forest model demonstrates an exceptional balance across all metrics, including precision and if1 score, indicating that its bagging approach was more suited to the heterogeneous nature of radiomic data than the boosting method we test. After applying Lime creates a local surrogate models by perturbing input data to see how prediction changes. In our analysis, we found that for malignant cases, BRAT 3, 4, and 5, as you can see, the model consistently prioritizes features like original run-length non-uniformity, a measure for test-to heterogeneity, and descriptors such as speculated or defined margins. This is a crucial finding because there are the exact same hallmarks radiologists use to identify invasive carcinomas. We have essentially validated that our AI is scientifically grounded in established medical knowledge. The validation of our explainability analysis was perhaps the most rewarding part of this research.
Excuse me, Anna.
Yes?
Just a gentle reminder that 2 minutes of the presentation will be left, so can you please wrap it up?
To finish, in conclusion, our research demonstrates that integrating radiomics with explainable AI provides a powerful framework for breast cancer diagnosis, and our random forest model proves the predictivity power of quantitative imaging, and explainability line offer the transparency required for clinical adoption, transforming AI black box into a collaborative diagnostic. For future work, we intend to validate this framework on diverse imaging modalities such as tomosynthesis and ultrasound, and also maybe try to another pulley datasets. And thank you for your time and attention.
Hey, a quick question to you. It's like, which feature selection algorithm did you use in your research?
For feature selection?
Yes.
What? Can you repeat, please?
Sure, I'll repeat the question. In your work, you have used the words that you have had a data set, and from the data set, we'll be having so many features. So you have extracted the few features which are required for your research. So for the feature extraction, which algorithm did you use?
And random forest and EasyBoost. And the two of them.
And from where did you get the data set?
Can you repeat?
Yeah, from where, from which site did you get the data set for your work?
And for the medical web.
All right, over to you, Dr. Prin.
Actually, it's nice, but how do you call? I think that. Do you think the doctor is okay with you for this one? But I think for this one, the doctor is okay with this one. Do you talk with the doctor on this?
And yes, one of the co-authors is a doctor. So the medical final analysis it was done by her. So it's okay with that.
Okay, good. So I think, and you have many cases for this one because I think this one it will help people a lot for this because it can help about the cancer but because my family actually is a doctor in the cancer as well, so they take time a lot for reading the film for this one. So I think the next step is to make it more confident that the patient can do this one, doctor can try this one. Yeah.
Yeah.
Yeah, that's it. Yeah, I think it's fine. Thank you.
Thank you, Ainhoa and the session chairs. With that, we move on to the last presentation of this session. I'd like to invite Husseini Inusa for his paper on intelligent system for managing cybercrime in Ghana.
Thank you so much. And thank you for giving me the opportunity to participate in this conference. I am Husseini Inusa from the University for Development Studies, Ghana, in West Africa. I hope you can all hear me. Can you hear me?
Yes.
Okay, thank you. So my presentation is on intelligence systems for managing cybercrime in Ghana. This is the presentation outline. The introduction contains the cybercrime trend in Ghana, the challenges of cyberspace of Ghana, and the opportunities in the cyberspace of Ghana. Then the methodology, I use a design science approach, and it was multidisciplinary by nature, so I used focal group discussion. I also did some consultation of the experts and authorities in cybercrime. Then under the design, I use diagrams, that's the UML diagrams. So the proposed use case diagram is presented, and then the proposed sequence diagram is also presented. So that's the outline. The objective is just to identify the appropriate intervention for managing cybercrime in Ghana, and also to propose an intelligence system to manage cybercrime in Ghana. Now, the digital cyberspace of Ghana. Ghana is a peaceful democratic country, and it is well known for the freedom of speech and association. And as a result of this, many people move in and move out. And as digital technology advances, social media becomes a source of information. And this freedom of speech and freedom of association manifest in the way people create content and share. They also go online and do a lot of things that affect the digital space of Ghana. On August 23, 2017, the federal jury in the United States indicted a notorious Ghanaian criminal, and that was in the Western District of Tennessee. It was an issue against the country. In a more recent case, the Southern District of New York also extradited 4 Ghanaians for cybercrime worth over $100 million, and that is huge money. According to the Ghana Broadcasting Corporation, Ghana lost about 23.3 million Ghana cedis in the year 2024, and that is close to $2.3 million. Now, the challenges of the cyberspace of Ghana. One is inadequate infrastructure. Ghanaians do not have enough infrastructure to manage cybercrime. Next is inadequate cyber education. People are not aware that education is not going on in the country. So many people are not even aware of these issues. We also have uncertain legalities, making it very difficult for people to be prosecuted. Then we have territorial issues as a result of the movement of people coming into the country and going out. Some of these people who are engaged in the crime are foreigners, and it is an issue. Another issue is the culture. Culture affects ethics by determining what is right or wrong. So in most cases, it becomes difficult, even convincing people to know that what they are doing is the wrong thing. Now, the opportunities in the cyberspace of Ghana. We have already existing laws such as the Cybersecurity Act 2020. We also have the Electronic Transaction Act 2008, the Right to Information Act 2019, and the Data Protection Act 2012. And these are the laws or legal instruments providing the foundation for us to fight cybercrime. We also have special bodies such as the Cybersecurity Authority and the Cybersecurity Unit under the Ghana Police Service, alongside civil society organizations that are helping or collaborating for us to address the menace. Now, the methodology employed, I said earlier, it is a design science approach, and it is multidisciplinary by nature. The reason is to accurately identify the interventions that can accurately address the cybercrime as a menace in the Ghanaian digital space. So engaging stakeholders will help in knowing the appropriate strategies that are supposed to be in place. Now, 2 key approaches were used to consult the stakeholders. One was the focal group discussion, and the second one was consultation of experts and authorities in cybercrime. For the focal group discussion, stakeholders participated in the group discussion on the challenges in the digital landscape of Ghana. And these stakeholders include civil society organizations, security services, senior high school students and teachers, and then youth groups. So 23 of the representatives were from civil society organizations, 7 were from security services, 13 were teachers from senior high schools, 26 were students from senior high schools, and 33 were people from youth groups in the country. And the aim was just to deliberate on identifying the challenges and the appropriate interventions for the digital landscape using pairwise ranking. Now, when we did a pairwise ranking by asking for the challenges they think we have in our digital landscape, 4 major challenges were seen: vandalism, cybercrime, inadequate infrastructure, and inadequate technical knowledge. When we do the pairing, or when we finish the pairing, it was realized that cybercrime was ranked first, followed by inadequate technical knowledge, and then inadequate infrastructure was next. Vandalism was ranked last. So it is clear that the major challenge of our digital landscape is cybercrime. When the cybercrime was looked at in a problem tree manner, we observed that the poor cyber laws in the country and the inadequate infrastructure leads to lack of cyber education. What to use to educate the people is even a problem. Then this leads to the cybercrime we are facing. And the cybercrime will lead us to the lack of trust. Ghana is losing the trust from the international community. Also, we are prone to conflict as a result of this. And then there are huge financial losses that affects the economy of Ghana. Now, the consultation of the experts and the authorities. Cyber law experts and cyber security authorities were consulted to know the threats of the cybercrime in Ghana. And the views expressed in this particular aspect was in line with the stakeholder consultations that we got. And further information from the stakeholders collaboration, we engaged the Ghana government, the civil society organizations, the cyber security authority, the media, cyber law experts, national security, and even the private sector. And these stakeholders are the actors or the people for the proposed intelligence system for managing the cybercrime in Ghana. Then the proposed use case diagram. These are the various actors and the aspects of the system they will be interacting with. So we have cyber education as a component of that system, threat monitoring as a component, awareness creation is a component, incident response is a component, investigation is a component, and then prosecution is another component of that system. So these actors, they all interact with components in the system depending on the role of the actor. The media, for instance, they are more engaged in the cyber education and they are also engaged in the awareness creation. Then a sequence diagram was used to understand how information will flow in the system from one actor to another. So in the system, we definitely need some support or funding before it can work properly. So the government of Ghana, if funding is available and it is sent, the Cyber Security Authority will receive the funding alongside the cyber civil society organizations, and it can lead to collaboration where the national security will be part, and then cyber law experts will also come in, and then the media will help in sensitizing people. The alert tips, media can give people information, and anytime somebody is under threat, we can get information back. If we are well educated, explanations can be given by the experts on the nature of the threats and how to avoid it, the incidents that we respond to, and then our incident handling will improve. And the government of Ghana will have better reports for cybercrime in the country in order to manage it appropriately. Now, in conclusion, the cybercrime is now a social problem in Ghana. It's not just a technology problem. And it undermines the trust international communities have in Ghana, which in turn affects the Ghana's economy, as some online payment moves such as PayPal and others, Ghana is denied the opportunity to be on those online payment moves. And it is making it difficult for us to make online transactions. So this trust issue is affecting the country and affecting the economy. Then the development of an intelligence system to manage the menace cybercrime in Ghana is an essential step towards strengthening the cyber security in Ghana because other countries are affected. It is a crime committed across the globe. Then the collaborative approach will provide an effective and proactive means of detecting and mitigating cybercrime in real time so that there won't be so much delay, which will result in so many losses before we think about investigating to get who is behind the crime. So this solution will promote collaboration among key stakeholders while upholding the ethical and standard privacy protection issues. Then the system will not only be used, but will also enhance cybercrime management and support the group of secure, resilient digital economy in Ghana, creating room for sustainable digital transformation. Thank you so much. I'm grateful. So that's the end of my presentation.
Yeah, thank you, Doctor. And coming to your research work, I just have one question that when you have run this study of the cyber crimes in Ghana, so what was your observation?
Yes, it was observed that the trend is increasing because in the past, it wasn't like this. And as indicated, in 2024, the cybercrime rate increased twice that of previous years, and that is very alarming. It is putting the country in a very dangerous position in the international market. And the trust many countries have for Ghana is reducing. And those criminals that were caught, as indicated in the introduction, they are Ghanaians. So it affects the trust people have for the country.
Okay, next one
All
is
right,
me.
all right. Good luck
So,
with your research. Yeah.
yeah,
Yes,
okay.
Dr. Prince.
Oh, okay. Dr. Priti, do you want to ask first? Sorry for this.
No, I'm done. I was just giving him best wishes for his research. You please ask your questions, Dr. Prince.
Okay, thank you very much. From the government perspective, what institutional structure would be required to enforce coordinating among stakeholders, and how would accountability be enforced for this one?
Okay, if I heard you right, you are asking for the channels through which we can enforce to combat the menace. Is that a question?
Let me send in the chat easier because I just
Okay.
type it, yeah, to make sure. Yeah, your work is nice. Your work is nice. But I think from you have to beware a bit on the governance stuff like that. Yeah.
Okay. Okay.
Oh, sorry. I think I sent to. I know. Okay. Sorry.
Okay, so the question is from governance perspective. What institutional structure will be required to ensure coordination among stakeholders, and how will accountability be enforced? Thank you so much for this question. Already, we have the Cyber Security Authority. So this is an institution that is already in place to fight cybercrime. So they are in charge of the coordination, and they are those who will collaborate with other stakeholders. So this particular system is actually coming in to facilitate their work and make them more efficient so that they will be able to combat the menace.
Yeah, okay. Wish you success for this one. Should be nice.
Thank you.
Oh, Christopher, have anything?
Yeah.
Yeah.
Yeah, thank you very much. I think that thank you very much, Doc, for the presentation. My question is that from your study, what is the most prevailing cybercrime that you identified in Ghana, and what recommendations have you put forward for government organization to be able to implement to actually help this particular menace?
Okay, thank you so much for that question. Online fraud is the most dominant among the cybercrimes in Ghana. And as indicated in the introduction, that is what is costing the country a lot. Millions of Ghana cedis, millions of dollars are going away as a result of this crime. And it is affecting the trust people have for Ghana. So even online transactions, people doing business with Ghanaians, they are now being very careful. So that is a major issue. Thank you.
I asked the question because I'm a Ghanaian as well, so I wanted to know about your perspective. So what recommendation are you, or did you actually put forward for government organization to be able to follow through to make sure that these particular menace actually reduces, if not actually kept completely?
Okay, so the first recommendation is the cyber education. I am emphasizing on the education because even if we have sophisticated laws and people are not educated on how to behave online, we'll still have challenges. So cyber education is the first step. Then secondly, we have to strengthen our cyber laws. And thankfully, the government is making conscious effort in achieving this. A bill was passed recently regarding cybercrime. And I think if we continue this way, with time, we will be able to improve and overcome this menace. Thank you.
All right, thank you.
Thank you, Dr. Fassini, Christopher, and our session chairs for this engaging discussion. And with that, we have come to an end to all the sessions and to all the presentations in this session. I'd like to sincerely thank all the authors for their excellent presentation and valuable contribution to this session. I also extend my gratitude to all the participants for being a part of this international conference. I hope this session was both informative and insightful. On behalf of the ICICT team, thank you for your continued support during the 11th edition of ICICT, as well as the previous editions. We look forward to welcoming you again for the 12th edition in 2027. All presenters will receive their digital certificates via email within 2 working days. The publication is expected to be available within the next 7 to 8 months. We kindly request your cooperation with ICICT 2026 team during this process. I would also like to express my sincere thanks to our session chair, Dr. Prin and Dr. Preeti Parvekar. And as a token of our appreciation, we would like to present this certificate. So.
Okay, talk a bit. Okay, thank you very much. And I think all of you are nice for presentation. As we know that we are in the technical room, but please be prepared for all the AI governance and ethics, because if your work is well, but this one will be destroyed in the future. So beware of this one as well for your work. Okay, thank you very much and good luck.
Thank you, sir. Dr. Parvekar, would you like to have a few words?
Yeah, thank you, Sanskriti. And it was lovely to hear all the research areas in a different domain. And I would like to wish everyone good luck for their research work. And it was lovely to meet Dr. Prem online. Thank you.
Thank you all for your valuable presence. May I please request everyone to turn on your cameras so that we can have a snapshot of this wonderful session. Okay, thank you. Oh. If anyone else would like to please turn on the cameras, that would be great. Okay. Thank you all for this great session.
Yeah, thank you, everyone. Bye.
Thank you. Bye.
Have a good day.